So I want to take this a step further. I really want to understand what the waveforms are coming out of the power supply and what comes out of the signal wires. So the first thing I'm going to do is I'm going to desolder the loads. So this is the first one. I'm going to desolder this fan. Just like that. And I am going to desolder the heating element, which reaches in from the bottom. Okay. So that's good. Now we have this all alone. And I think I'm going to remove all the strain relief because it's making everything more cumbersome. Be careful not to snap the wire. The zip ties are brittle either way, which is why I don't advocate for them being used as strain reliefs. Okay. At least not in this application. Alright, that's good. And now I want to remove this. I'll cut the cage right over here. Okay. There we go. We have the power button right there. This is a bit annoying how all this stuff is tangled up. Anyway, I think I can live with it this way. It's no big deal. Alright. First thing I want to do is I want to actually measure the output voltage on both of these without load. That's exactly what we will do. This is gonna have too much glare on it and it's too bulky. Get the other one. Yeah, that should be good. Do I need the soldering iron anymore? I don't think I do. I can unplug it. Because I also need to make room for when I power up the board. Okay, so that's the soldering iron unplugged. Alright, so first of all is the output that was connected directly to the fan. Let's see. Okay. Also want to make sure that the other side doesn't short. See. So when I turn the knob, the voltage is going up to 12 volt, as it's indicated over here. Is it DC or AC? Okay, so it's all DC. And if I lower it, what's the minimum? Will it actually go down to 5 volts? 6. Okay, it's at 5 volts. But this 5 volt, this variation, is it a PWM signal, like we spoke about before? Or is it going to be that spiky signal? Or is that because of the motor? Like a sawtooth wave or something. Let's hook up the oscilloscope. So we have the oscilloscope hooked up. Let's see. It's completely DC. And it's changing as I change the knob. Maybe I can give you a bit of a wholesome view, a broad view. Alright, yeah, that's good. So I'm turning the knob over here. And my voltage is changing. Minimum 5 volts, maximum 12 volts. So that's really good. And it's going down. Now I want to take a look at the other side, the one where the heater was connected. Let's hook that up. Turn it back on. That's the PWM. All right. Okay, and when I turn it, it's as if not much is changing. That's a bit weird. So that's the PWM signal, square wave, in other words, for the heater. But nothing seems to be changing much. Let's take a look at the voltage. It says over here, let's have it at let's change the coupling. I forgot to change the coupling. We put it AC coupling. Okay. Okay. Well, there's hardly any change. Let me hook it up to the multimeter directly. I don't know if there's a polarity issue because both wires are red. Okay. We literally have 220 volts AC. Which makes sense. I mean, it's a heating element, but the signal is a bit weird. So now we know that these two are giving 220 volts and this is giving variable voltage, which is pretty cool to have in a single power supply. Now I'm curious about the signal wires that come through here. What's the deal with them? I want to test this one more time under the oscilloscope, that 220 volt signal. I want to see what that's about. It got me very curious. Okay. Time base. Nothing. Yeah, nothing. So it's just 220 volts, but it's beyond the measurement units, the measurement capabilities of the oscilloscope. And when I turn it off, yeah, it's gonna go obviously. Well, okay, that was pretty cool. Let's put these to the side. So the airflow, the airflow knob will control 0 to 5, from 5 to 12 volts, sorry. And the heater is going to be directly 220 volts live. But I wonder there's one more thing I'm curious about, which is this potentiometer right here. Can we find out where it's connected? I'm gonna hook it up again to the oscilloscope this time, and I'm going to see what happens if I vary that potentiometer. So like that. Okay, I'm gonna need to get a screwdriver. This one should work. And we can plug it in and turn it on. Okay. Be careful not to zap myself. Let me change the time base a bit. Okay. If I put the screwdriver here. Not much is going on. I really am not sure. I can't tell what's the deal. If I hook up the multimeter directly, I can take it from here actually and plug it into here because I have the BNC adapter. Okay. Voltage, AC. Let's get plugged in again. Okay, we understand that now. 16. Not really sure either. Anyway, nifty piece of equipment. I would, because this is like two power supplies in one, you have this part and you have the big bulky part that's actually supplying it over here. So that's also cool. Also cool. Later on, maybe we'll take a look at this part and what each of these colored wires carry, what type of signal they're giving us.